The pillars of object-oriented programming. Well, there are 4 pillars when it comes to object-oriented programming. Our first one being encapsulation. Then we've got abstraction, inheritance, and polymorphism. Now, the polymorphism, this one you will cover in DSA, data structures and algorithms. So we're not going to touch on that one. We're going to be looking at these other 3 pillars. So what is encapsulation? Well, it's used to hide information from the outside world. And you hear that, oh, let us encapsulate that all into one. So we encapsulate it so that it's not known outside. What we're doing is we're enclosing both the data and the methods within the object. So it's not one or the other, but each object is self-contained with its data and the methods it requires to manipulate that data. What do we say? Encapsulation allows an object's methods and data to be treated as a single entity, and that's what I was just saying. It's all in one. We conceal the object's methods and data away from external sources. Okay, so they're not based here, there, and everywhere. It's encapsulated. You'll notice that word, encapsulated together. Another term that is used is called information hiding. Abstraction. What is abstraction? Well, there's lots of myths around it, but I think Dijkstra summed it up really well when he said the purpose of abstraction is not to be vague, but to create a new semantic level in which one can be absolutely precise. And you will find these sayings and things from Dijkstra all throughout computing. Let's have a look at abstraction. What we're looking to do is not simplify, but to reduce complexity. Okay? We're looking to take something that's really complex and break it down into something that is simple. And this is the other thing when we abstract. We're attempting to isolate the impact of change, because if we can abstract it away, we reduce that impact when we make changes. Not that when we make one change here, everything over here breaks. And that's what we need to be really careful of. So abstraction allows us to do that. Inheritance. The next thing that we're really looking at. With inheritance, we acquire the traits of our predecessors. I have inherited things from my parents, who have inherited things from their parents, and the chain goes on, and it's passed down generation to generation. That's a little bit with inheritance in object-oriented programming. We inherit from other classes. Okay? For instance, cars have similar traits to each other, all right? So we don't really want to make a class that is for every single make, model, etc. We have our generic things and we inherit from that. So we create this parent class or parent object, and those that descend from it inherit, yes, all the attributes and all the methods that the parent class possesses. Polymorphism. Now this is a great word, polymorphism. Say that 10 times. It'll be fun. All right. Have you ever opened a door? And you're going, oh my goodness, seriously, David is asking that question. Yes. Have you ever opened a book? Some of you might be no. No, we've opened a book. Have you ever opened a bank account? What about opening a shop? Or opened something else? Now, I'm hoping you've noticed that all of those things are the same, open. But you would never describe to somebody who needed to open a bank account in the same way. You'd never describe opening a bank account in the same way you would opening a door, would you? No, you wouldn't. So polymorphism is where we use the same thing to do different things. So open, there's many different ways to open things, okay? And we'll see that as we go on through the semester. Same task done differently.